Hello, students. So until now, the material that we covered, the lectures, should have basically given you a basic understanding of what is ergonomics and what is ergonomics dealing with. Now, we will focus on a new section which deals specifically with parts of ergonomics that will help you later with your project needs. As I mentioned before, ergonomics is a very wide discipline and it covers many areas. So it depending on which area you're dealing with, what are you designing. There are many topics. Now we will focus on specific topics from now till the end of the lectures, not only this lecture, even the next one. We will focus on specific topics that will help you with your projects. So, the general knowledge that you now know about ergonomics, what is ergonomics, what it deals with, this will also be applied, of course, in the projects, but these sections deals with specific things that you need. So, for example, now, when we get to the project, I will explain to you again what it is about, what you should do, but the first project, you will be dealing with basic systems. So if you remember, one of the lectures that we covered before deals with system design. And I explained that what are the three types of systems, okay? Go back and revise if you forgot. So the three types of systems, there are basic, mechanical, fully automatic. Now your projects will deal with the basic systems and the mechanical systems. The first project, the basic systems, which are hand tools. We categorized the system types according to how much manual control versus machine control there is. So the manual, the basic manual systems are the most simple ones. They are the hand tools that, like these, if you see the pictures, these are hand tools. The cutters are hand tools. This is a hand tool. These are all hand tools. These are all types of hand tools. There is no power involved, no electricity, okay? Most of the work here is done by who? The human. So in basic systems, which are hand tools, most of the work is done by humans. You have to put the work into the force, the pressure, whatever you need to do to actually do whatever you want to do, the task, okay? Now, each of these hand tools, okay, its function is different. It is designed for a different function. That's why these shapes are different than this shape. These shapes, look at each one of these tools. It's different than, sorry. So each of these shapes, okay, of each of these tools is different. Why? Why is this tool shaped in this way? Not because the designer wanted to make it beautiful. No, because it relates to the function. Remember the function, the word function is very important. So what is the function of this tool? I need to ask myself before I design it, so that I can design it in a way to meet that function. Well, with its shape, and also to meet the needs of the human that will be touching it and using it. So each of these tools have different shapes because they perform, they are designed for different functions, and the human performs different tasks with each of these tools. Sometimes you rotate, sometimes you do this movement, so each tool is different. Now we will see in detail some of the requirements, okay, for basically when you design a basic system, what you need to consider. Now, you need to always remember that there are two main types of grips. What is a grip? This is a grip, okay? When I'm trying to grip something. Okay, this is a grip. This is a grip, okay? So there are two main types. And this is important for you to recognize what is the type in the object that you're designing, so that you can design the shape correctly. Everything relates to the shape, okay? Now, a power grip is used when, for example, holding a hammer, okay, which uses strong forces, strong force. So your whole hand, the whole hand wraps around it, okay? So I have some tools here, like this one, for example, okay? Now, what's the function of this tool? It is to cut, okay? So how do I cut? I need to grab it with my hand, the whole hand, and I need to use force, okay? So I need to push, this is using force. So to do this accurately, I need to be able to have a strong grip with my whole hand, not like this. I can't hold this like this and cut, okay? You need to grab it strongly. Okay, so this is a power grip. When you need to apply force, all of your hand needs to be able to grip this surface here, which is the handle. Remember what we discussed before? A system consists of what? Of the product and the human, and the touching points between the two, the relationship we have, okay? So the interaction we have. So I have an interaction now with this tool. When I start using it, okay, we are interacting, we are a system now. Now, what is it that I'm doing with this tool? This very much influences the design of this tool, the shape design, okay? Now, so sometimes some tools are designed for a power grip that relates to what they are designed for, what is their function, okay? So a power grip, you need to be able to put all the hand strongly to hold the tool and to use it in with some kind of a force. A precision grip, on the other hand, is when you have to do precise work, detailed work. Like, for example, when you hold a pen, okay? Do you hold it like this? No, you hold it like this and very carefully use it. This here, it's sometimes you use it for power, as a power grip, okay? So it must be designed for power grip, like when I'm cutting something really heavy and big, like a cardboard, I'm using quite force. And sometimes I'm cutting more precise work. So it has to be designed suitable for both tasks. So the two grips, you always, when you analyze hand tools, analyze, meaning finding mistakes in existing hand tools in the design of this, you need to analyze. We described already before what is analysis, okay, and the two different methods that you will use. So you need to be able, so these two power grips, okay, the power grip and the precision grip, the two types of grips, you need to be clear about when you analyze a tool for its mistakes. And also when you design a new tool, like, okay, I found now through analysis some mistakes in this tool's design. The next step is, after I recognize the mistakes through analysis, it's time to start designing a better one that meets the function better, that can improve how the human uses this tool to make the tasks more safer, more easy, more comfortable to do with this tool. So you always need to recognize the two types of grips before you can design a successful hand tool. Now, because hand tools are mostly, well, always actually used with the hand. That's why they are called hand tools, okay? So you use them with the hand. So you need to understand the three things that make the hands and wrists, the wrist, this is the wrist, okay, uncomfortable. Three things. Repeated muscle use, which can lead to painful tendons and muscles. Now, even though you don't see the muscles in your hand, well, most of our hands, we don't see the muscles, they are muscles in here, okay? Now, this makes it possible. So there are muscles and tendons inside. So this is what makes me able to move my hand, okay? Now, if I have to use my muscles in a repeated way, okay, for a long time, this can lead to pain. So I will start feeling pain. Now, also, if I have to use a tool that creates excessive bending, you know, bending, this also causes a lot of problems and discomfort. And the amount of effort or force used. So if I have to use a lot of force while using a tool, a lot of force and effort, this also will create pain in my hand. Now, imagine if you have the three together: repeated muscle use, excessive bending, amount of force. So now it will become a disaster situation. And also the degree, how much repeated muscle use I use, how much excessive bending, what's the amount of force? All of these questions, they are not straight, they don't have a clear answer. You must look at each one of them and decide for the tool. So you must observe the whole situation while the human is performing a task with this tool. So how long do I use this tool normally? Okay, every day, okay? And while I'm using it, what movements do I make? For example, this one, I'm using a rotating movement, okay? Now this rotation, this is a type of excessive bending. So I'm bending my hand in a way that after a certain time, it will become uncomfortable and painful. And also I have to grip it strongly and I'm putting force, but how much force? Okay, it's different from tool to tool. You need to observe the whole situation to decide where are the problems in the design here, to know exactly where to focus your solutions. So these three things are important that make our hands and wrists uncomfortable while using hand tools. Keep this in mind always when analyzing and designing hand tools, which you will deal with in your first project. So a combination of high force, repetitive movements, repeating the movement over and over again, and awkward, bad, extreme joint position. So the joint has to move in an uncomfortable way, increases the likelihood of injuries to the arms and hands. So it's not only the hand you're injuring, it's the whole arm. Even your back might start hurting because of this, okay? Now, the symptoms may be felt quickly or they take a long time to develop. After using a badly designed tool, you may immediately have problems with your hand and arm, or it will take several uses, a period of time until you feel the effects of the bad design. Now, most hand tools have been designed in a way, to make them acceptable for the use of as many people as possible. So if I'm using this hand tool, and then you are using this hand tool, it should somehow fit with our bodies. So, but now, many hand tools have been designed considering the average human measurements. So this creates some problems. If you remember, when we discussed anthropometrics, we discussed percentiles, the 5th percentile, the 50th, and the 95th. And I said that the 50th percentile is the average. And the average is used in some designs, the average measurements of the human, but it can create some issues. Like if you are if your hand is extremely small or very big, now it means using this tool will not be comfortable for you. So many hand tools have been designed for the average. Now, also, their focus is most of the time on designing the hand tools to fit with the hand sizes of men. Because usually, most of the time, it's the men that are using tools, okay? It doesn't mean women don't use it, but most of the time, men deal with tools, okay? So the shape of the tool is focused on the male hand, not the female. And we mentioned before that men have different sizes than women overall, okay? So considering this, the hand sizes of men are bigger than women. So if this hand tool has been designed considering this in mind, if, for example, a small female wants to use this, it will be a little bit uncomfortable, okay? Now, there are tools that are designed considering gender in mind, the differences in sizes. So these, for example, tools have been designed in a way that will fit men's proportions and men's measurements better. These tools are designed for women. So these are more comfortable for the sizes of females. So again, you need to consider who are you designing for? Who is your target group of users? And whether you're designing for men or women, that is also important. It's as important as what is the age group and other details about this target group of users. Do they have a disability, or are they just the average person? And other details. So your target group of people that you're designing for, it's very important, okay, to decide which measurements you will use in your design to fit the needs of these particular body types, okay? So this is very important. Here again, we have examples of hand tools. Now, look at this. This is the same tool, the same type, okay? But it's designed in a different way. Look at the handle. Look at this handle. So it's being used like this, grip like this, with a straight arm, and like this. The other one, which is this one, it's a straight grip, and it has to be used in this way. Now, as a design, this one is much better than this. because here I have to bend my hand in an uncomfortable way. So my wrist here will start getting painful if I have to use it repetitively, okay? This design, on the other hand, lets my hand rest in a natural way. So it's more easier to use it. Here again, look at this tool. This is the same as this, just the difference is the design. Do you see the design of the handle? One of the designs makes it more comfortable for use without health issues arising. The other one creates some issues because of the way the hand bends, where is the pressure points, and so on. Okay? So you have to, when you design things like that, tools, okay, you have to consider the whole dynamics of the situation. And if you remember, when we talked about task analysis, okay, where you have to describe each task state, and then you have to decide where are the touching points between the human and the device. And then you have to describe the actions of what goes on. The actions will tell us the whole picture of what exactly is happening. And this will help you discover design problems in this, for example, tool. So everything starts, before it goes to design, it has to go through analysis, analyzing existing products for their design problems so that we can solve them as designers. We are problem solvers, okay? If you as a designer cannot solve problems, then what's the point of being a designer, okay? Okay, let's continue. Here are more examples. Some hand tools, you need to use two hands, like this one, for example. Okay, so the force applied is so big, and the balance, you need to keep balance and force to apply. So you need to use one hand here, another hand here. Well, this is a similar tool. So if I look at it, I mean, if I want to use it alone, I will not be able to balance it if I want to cut like this. But I need to support here with my other hands to cut properly. But it's not a perfect design, this one. I mean, it's not designed in a perfect way. So it has a lot of problems. So the shape of the tool is very much helping, okay, in this area. What is the shape? The shape has to be in a way that it will be able for you to perform the task well. So what is it? What is its function? Okay. So you can perform the task, but to make it comfortable for human use and not to cause injury, the shape also has to be designed for this, to meet the human needs and to keep the human safe and comfortable at all times, and to reduce the possibility of getting tired, getting injured, anything negative. You have to keep always, in ergonomics, everything has to be designed to make everything in a positive way. Nothing negative should be left. So this, for example, is the same like this tool again, but look at the design of the handle. Look at the handle design. There is the difference, okay? There is the difference. So here, how does the arm and the hand hold the tool and use the tool to perform a task? And here, so this is a more comfortable design for the hand. It leaves the hand and the arm in a more natural position. And we discussed before, natural and unnatural positions of the human body. Remember the principles of ergonomics, okay? And then we had also discussed about natural and unnatural positions. So everything must be kept as naturally as the human body is designed. So the tool has to fit with the human body design. You design the tool for the human body. Okay, always this is you must keep in mind. Look at this tool. Again, this is the same, it performs the same function, okay? But the design of this is different than the design of this for a specific reason. The same reason this has a different design. For the same reason, this tool is designed in a different way, shape-wise, okay? Now, so anthropometry measurements for hand tools. Hand tools, again, they are used by the hand. So if an object is used for a specific body part, which is the hand in this case, we need to understand everything about this hand, measurement-wise, okay? We need to understand the measurements very well. So here are some very simple, actually, measurements. You will find a lot of other anthropometric hand measurements with a lot more detail if you search and if you need to for certain designs. Here are just the general, like, you know, the hand length, the palm length, the thumb length, the index finger length. So it's like very basic, but it's not only the length that's important, it's also the width sometimes. Other details in the hand shape, like, for example, not only the static, this is a static without movement measurements, but what happens when I bend my hand? For example, if I do this, for example, what is the space here inside? What is the, for example, the diameter of this? It's very important in hand tools. Look, okay? So this diameter of this tool, how much to make it to fit into the hand? And not only to fit, it has to be, it depends on the function of this and the strength and power I'm using it with. So is it more comfortable if this is larger or smaller as a diameter, okay, of this circular section, okay? This relates to the hand. And how much this here opening is also relates to, are you a male or a female? What, are you a small, are you from the 5th percentile or the average or the 95th? So it has several, you know, things that influence the measurement. But for you to be able to design anything, you must decide which of these to use, which of these measurements to use. So will you design your tool for the 5th percentile, which are the small people, and which for both men and female, male and female, or for both of them? So here the blue are the measurements for the men, and the red, the measurements for the female. It tells you here, okay? So the hand length of the small men is, for example, 173, okay, whatever they use, I think in millimeters, okay? So 17.3 centimeter. The small female hand is 15.9 centimeter, length-wise. What's length? This is here, do you see A? This is A, so from here to here, okay? These are the measurements for the small people. Now the average, they're a little larger, the hands. And if you design for the 95th, they're even larger, but it depends. So for hand tools, sometimes you have to use these measurements, sometimes you have to use these to fit all of these, but it depends on really what you are designing. Sometimes this is the most correct measurements to use, but then maybe the small people will have some issue. It will be a little bit too big for them. So sometimes you have to really design also for both genders to separate them, because the measurement wise, it will not fit comfortably. So a lot of decisions to take before you design something. But you need to understand what is in tables like these, anthropometric measurement tables. You need to understand and select the measurements you need. So if you design for these, then you take these measurements. Now, if you design for both male and female, you need to consider them together, okay, as an average, this, and design to suit both of them. Okay, you look at the letters again, and you see here which of the information you need. And of course, you need to understand what is the function of this tool. This tool has a different function than this tool. They function in a different way. I move my hand in a different way when using them. This one, I rotate. This one, I make this kind of movement. So the human-machine touching points are different when I hold this and when I hold this. They're different. Or if I hold this tool, okay, different touching points, different power, different types of grip, precision or power grip, different movements you perform. Each tool you perform different movements with it. You hold it in a different way. You use different strength, everything is different. So what is the function of this? What should it do? This you need to identify. Okay, you need to identify. And then all of these issues regarding the tool, you have to make them fit into, to fit the human size. Which human size? You have to decide which you think is most suitable for your target group of people. And design according to these measurements and other details regarding hand tools that we discuss. So the hand tool has to, in a way, conform to the geometry of the hand. So you need to understand the shape, the geometry. It's not only the measurements, like how much is this finger length, how much is, it's not enough. The geometry, all of the hand, even in movement, okay? So the hand tool has to fit with this geometry. So you can find a lot of recommendations regarding hand tools, like for example, a certain type of grip, you know, the way you hold a tool. It's recommended, for example, for these tools, to have a handle length of 5 inches. What are 5 inches? You have to, if you want to know in centimeter, you have to transfer 5 inches equals how many centimeters, okay? Be careful if they use inches sometimes, or centimeter or millimeter, okay? The units are very important. The diameter, on the other hand, which is from here, so there is a length for the handle and a diameter, okay? The diameter 1 to 1.5 inch. This is the recommendation for these kind of tools. Now, when you have a different type of tool, so this tool, like this one, you hold in a different way. So your hand is like this, okay, when you hold it. Now this one, it's the movements you perform with it is different. So the measurements are different also. So what is the recommended length and span and so on? Here also a recommendation to avoid hand tools that the handle, you see the handle, it ends in the middle of the palm. Like here, for example, it ends, because when you try to use this, if the handle is too short and you try to use it, it ends here, it will create some problems with how much force you can apply, how comfortable it will be to use. So it needs to be in a certain length to fit with the measurements of the hand. So when you use this product, to be comfortable. So here are more guidelines for hand tool design. I will go in detail over this information and discuss each one of them so that you understand what's going on. Tools that are too heavy will make you tired very quickly and will be difficult to control. Heavy, so heavy, okay? So if it's too heavy, you will have difficulty controlling it, and you will get tired, depending on how much you use it, but you will get tired, okay? Now, this doesn't mean that making a hand tool light in weight is a correct solution. It's how much. That's the correct thing. You need to decide how light, how heavy, and all of this relates to what is its function and use, and the task performed, and the human who will be using it. Okay? All of this always interrelate. So there is no single weight limit that can be recommended for hand tools. Nobody can tell you this is the correct weight to use. So, but in general, it should usually be possible to carry a tool in one hand, to carry it, okay, without strain. So if I pick this up, I should not feel that, oh, it's too heavy. I should not feel that. I should feel it's kind of right. So it depends on what is the tool, what is its function, what tasks I will perform with it to make the weight suitable. Now, sometimes certain tools are heavy and you cannot design them to be light in weight because of the materials. Like, for example, some tools you need to design out of metal and they need to be very, very strong. So this will add to the weight. It will make them heavier. Then you can design the tool to be used by two hands, not one hand, two hands. So both hands help you to carry the weight, to have more control over the tool and for support. So some tools can be extremely heavy, like, there is a device which unbolts the, basically the certain parts of the car. It's very heavy too. And it's not like you cannot pick it up. So what do? They basically suspend it from the ceiling. There is a rope that goes down. This holds the tool up. I am just pulling it down and using it. And then it goes back. So I am not carrying the weight. Something else is helping me because it's so heavy and there is no way they can make it lighter. Sometimes you have to use, as I said, metal, for example, very heavy type of metal. You cannot use plastic, okay? Because you will lose the strength of the tool. Like even small tools, look at this small tool. Can you make this part out of plastic? No, you cannot, okay? So the material choice, we will talk about this later, how to decide the material choice for whatever you're designing. But sometimes you are stuck with certain materials and this creates weight. So you need to find other solutions, other design solutions to make it comfortable for human use, despite the weight. Now, tool handles, the physical characteristics, okay, that are important in design. Physical characteristics, remember this, okay? The physical characteristics only, we are talking about handles now, because why is the handle so important? The handle, because this is the place where the tool comes in contact with the human body. Here are the points of contact. So the handle design is very important, okay? So the physical characteristics that you need to pay attention to. Remember this because in your project later, you will have to identify the physical characteristics and write about them of a certain tool. So pay attention to these. The diameter. The best size and shape of the handle will depend on the nature of the task. So what diameter should I make? For example, this tool, what is the diameter? Okay. Depends on the nature of the task I'm performing. And what type of grip? So do you use a power grip? Like, for example, for a hammer or certain tools that need power, okay? So handles for tools that use power grips must have a greater diameter. So the diameter must be larger so that you can hold it in a power grip comfortably. Now, if you use a precision grip, the diameter can be smaller. Now look at the diameter of this pen. So what is the diameter of this? It's much smaller than this. This tool you use using a precision grip. A precision grip, okay? You don't need it to be that big. If it's that big, I will not be able to use it in a precise way. Imagine I'm writing with this. It's a little bit uncomfortable. Imagine you're writing with this, okay? This kind of diameter. It's not comfortable. So, recommended diameter for power grips is 40 to 45 millimeter. So 4 centimeter up to 4.5 centimeter. The recommended diameter for precision grips is 8 to 16 millimeter, okay? This is in general. But these values are, as I said, in general. Sometimes you can, you know, have a variation depending on exactly what is the function of the tool you're designing and who will be using it. Another physical characteristic is length, how long, okay, the handle is from here to here, how long. The length of a handle should be at least 100 millimeter, meaning 10 centimeter, so that the end of the handle does not finish in the palm of your hand. This is the palm. So it doesn't finish, if I'm holding it, it doesn't finish here, okay? It should finish, to be more comfortable, it should be a little longer. So, ideally, now this is the least, 10 centimeter is the least, but ideally in a better design, the handle should be up to 13 centimeter, okay? This will be even more comfortable for most hand tools. So there is less risk of the handle doing damage in this case by compression of the soft palm tissues, because here the area of your hand is very soft. Now, if you have a hand tool that keeps pushing here, it will create a very uncomfortable feeling. So to avoid this, they make the handles larger, longer, so not to press on the soft tissue here. Here, on the other hand, you have a bone. You have here a more supporting structure, okay, than here. So this must be taken into consideration. Separation between handles. For example, what this means, separation between handles. Like this is a handle and this is a handle for this tool, okay? The separation from here to here, how much? So this is a plier. So this is a tool that uses one handle, okay? This is a tool that uses two handles. So what's the separation between them? The recommended distance separating the handles is between this number, okay? This is here in inches, this number in inches, we don't need it. So this number, 6.5 centimeter to 9 centimeter. Why this measurement? How did they choose it? According to the human size, the hand size, okay? So when I have to grip this, it shouldn't be so big that I cannot grip it, or so small that it should be just right. So when I hold this tool and use it, my hand should be comfortable. So this measurement hand, this tool has to be designed for me and for you and for thousands of people that will use this tool. Now, grips that are larger than 100 millimeter, which is 10 centimeter, will be difficult for some users. So if you design this distance to be 10 centimeters, some users which have smaller hands will find it difficult to use. Because if it's too open and I try to grip it and I try to press, it will be uncomfortable for my fingers to press, okay? So tools with larger or smaller spans will reduce one's maximum grip strength. As I said, if I have to open my hand too much and press, okay, I will have less strength here. But if the tool is a little smaller, I will have a lot more strength. But if the opening becomes too small, again, I will lose strength. And if this tool needs to be used using strength, a certain amount of force, then it should be designed with the correct measurements. Ridges. What are ridges? Ridges are these things here. Do you see here? These are called ridges. These here, this design here, are also ridges. There are many types of ridges, okay? Now, some screwdrivers you will find with deep ridges, like very heavy ridges, you know, along the length, and also other screwdrivers. This is a screwdriver, okay? You will find with smooth, like this one is smooth, no ridges in general. There is some here, a hexagon design, you know, but let's consider it a smooth one because it doesn't have these kind of shapes, okay, here, which are called ridges. So now, a smooth handle is best, okay, when there is a large surface area to grip. Okay, so if this here it's big, okay? Now, how big is another question, but if it's big, so it has a big surface area for me to grip, I can make it smooth, the handle, and it still will be comfortable. But if the handle is small, usually ridges are placed in the design so that they prevent the hand from slipping. Because when this becomes too small, you cannot hold it securely in your hand. It has more difficulty in holding. It can slip. If it's large enough, you can hold it. So you need to decide, does your tool need ridges or not? And where to place them? And what type? So the general rule is that if a handle is to be grasped and squeezed, so you need to grasp and squeeze, okay? It should spread the pressure over as large an area as possible, over the palm and fingers. So the pressure, when I squeeze it, it should be distributed over the fingers and the palm, not to be focused in one area, okay? So a lot of things need to be taken into consideration when you decide the size of this. So the diameter, the length, whether to put ridges or not. Okay, so a lot of decisions to be made for a design of a handle. So sometimes they put rubber here, like this is plastic. You see the yellow part, this is plastic, but the red, you see the red here, this is rubber. This is not, this is a type of plastic rubber, but the rubber is different than plastic. The plastic, when it's smooth, it's slippery, okay? Now the rubber prevents slip. So in this design, they added plastic, but also rubber. The red is the rubber. So when I hold it, it kind of, the rubber prevents from slipping while used. So do you put ridges and leave the surface smooth? Or do you add also rubber? Do you see here? Notice also the cross section. This is round, circle. Like this pen, for example, do you see here? There are ridges. But when, the cross section is what? Circle, it's round. Look at this here, the cross section of this. This is, so if you cut it, you will see a square. Now the square is more stronger when you hold something in your hand and it's of a square cross section. It makes the slipping less possible. It's a strong grip. It creates a very strong grip. When it's round, it's more easy to what? To slip. You see, it's more easy to rotate it. I can rotate this more easy than if this one was a square cross section. Now, the ridges also help. Now, if there are ridges, I cannot rotate it easily because of the design of the ridges here. If there are no ridges, like a smooth surface, it will be very easy to rotate. So what is the tool? What is the grip? How much strength? How to use it? What tasks to perform? All of these things matter for you to decide what type of ridges do you need, what cross section, where to put them. Okay, all of these decisions have to be made. Indentations. What are indentations? Indentation is this. Do you see the shape here? This shape. So indentations, they basically follow exactly your finger. How are your fingers shaped? Look at this tool. It has indentations. Do you see this? So when I place my fingers here, first of all, I recognize by the indentations that I should have these fingers here, the touching points, okay? Of these should be here, not like this. I don't hold it like this. I hold it like this. The indentations indicate to me, okay, how to hold the tool. Then they also help me to grasp the tool in a strong way. So my fingers here don't move easily because of the indentations. And the material here is rubber, which additionally helps me to keep my fingers in place, okay, while using this tool. Now, the downside of using indentations in designs is that, well, what if you have extremely small fingers? For example, okay, maybe the indentations will cause you to open your fingers much more than you want, creating uncomfortable feeling while using this tool. Sometimes the indentations are designed in a way that if you use, some users use this hand, some users use this hand, creating some problems. Now this here, in this case, they are designed to be used by both hands. They are comfortable here, comfortable here. But the sides, so what is this here? Size, how deep? How deep and what is this size, okay? This is very important in designing the indentations. But as I said, if you have very small hands or very big hands, these could sometimes create problems. So indentations also what encourage your hand to stay in one position. So there is no way you can use this tool in a different way, except put your fingers here. You cannot use it in a different way. The indentations prevent you. Now, sometimes this is good. You don't want the user to use the tool in a wrong way, to hold the tool in a wrong way, like cutters, okay? Like, for example, you must use the cutter to cut with it correctly like this, finger up and cut like this. Not like some students cut, I've seen, holding it like a pencil, like a pencil. I'm holding it like this and I'm cutting. Like if I'm holding like this. No, 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 no. This cutter should be used with the whole grip and finger here, not like this, okay? So now, having these indentations prevent the user from thinking to use it in a wrong way most of the time, okay? This is good in some cases and bad in other cases. Depends on what is the product you're designing, what is the tool. Okay. The guarding, what is the guarding? It's another physical characteristic that most tools have or don't have. This is this here area. You see this area? And here you have this area. This is a guarding also. In my tools, I have this here area. Do you see this? That goes up. This is the guarding. In this tool, we don't have a guarding. Notice that there is no guarding, but notice what they put. Let me see the light. They put here ridges. We described what are ridges. Look at these ridges. Why are they here? Why didn't they put it here? So this is smooth, and then you have these. This is because when you hold the tool, this finger is here. There is a design reason for that, okay? Not for beauty, for function. That's the main thing. This is put here so that when I put my finger here, it doesn't slip easily. So when I'm cutting, my finger does not slip, okay? So this tool does not have guarding, does not have this. So this is to prevent you from your finger to slip. Look at this tool now. It has a guarding because I'm using it in this way. Look at this finger. So this guarding prevents my finger from slipping. And it's very important in some tools, not your finger to keep slipping, because you will not be able to do the work accurately if you keep moving in the wrong way, and it will not be a strong grip. So this guarding, very important. And you need to design it and place it in the correct position depending on, again, what is this tool, how you will use it, like this, or also how heavy is it, how everything, every detail is connected with each other. Who will be using it? What size hands? How? Everything you need to answer. So many tools, you will find this shape placed here, which is called guarding, okay? And it's not placed for just to look beautiful. It has a function, okay? To prevent your finger from slipping while using it. Look here, this is also a guarding actually. So the finger is placed here and it cannot go beyond this point. This can create sometimes dangerous situation when you have a knife, okay? So you must prevent the finger from slipping. Here also the lower fingers, the finger that is from this side also prevent it from slipping. So do you need guarding for the tool you're designing or not? And what is its shape? And where to put it? All of this needs to be decided. Materials and textures. Every tool you look at, this tool, this tool, this tool, okay, this tool, all of these are tools. They are made from materials. They're made from materials. Now, and textures, okay? So the texture, what is the texture here? What is the texture of this material? So materials and textures are very important to decide what materials to use, what textures to use or not use, and where to put what, okay? So here plastic is put, here rubber, two different materials. Why? Other tools, what is this material, okay? Why is it used? It's also smooth. Why? Why did they make this out of plastic and this here is a rubber? Why? Why did they put these here also, in addition to the rubber? Why is this metal, not plastic? So the choice of materials and whether the material has a texture or doesn't have a texture is very important to decide. So to ensure a good grip handle, the handle of the grip to be good, sufficient friction must exist between the hand and the handle. Friction, okay? If there is no friction or the wrong friction type, it can create problems in the way you use the handle and the tool. So this is particularly important where a considerable force must be applied with a sweaty hand. So if I'm a worker and I'm working, my hands are all dirty, sweaty, and you know, when I hold the tool, like there is no enough friction, so my hand can slip, which is not a good idea. So hand tools should be made of non-slip and non-conductive materials. In general, we talk about in general. Non-conductive, meaning if there is a heat, not the heat to be transferred to your hand. Non-slip, not to slip. Okay, which materials are non-slip? Not only the material, but the texture. I can make a plastic that is normally slippery, non-slip, by adding texture. So texture can prevent this. So textured rubber, okay, for example, handles provide a good grip, reduce the effort needed to use the tool effectively. So textured rubber is a good choice, for example. And it prevents the tool from slipping out of the hand. Now, another important thing to consider, the material of the handle should be non-porous. What does non-porous mean? So, it means the pores in it. Like, for example, what if I have a dirty hand and I'm using this material? I put my dirty hand on it all the time, all the time, all the time. If it's porous, the dirt will go inside, the oil, the dirt, everything, and it will build up, okay? So it will soak up and retain oil and other liquids inside. So porous materials allow liquids and oils to go inside of them, which is not a good idea, okay? The handle of the tool, you use it a lot, and your hand is not always clean. So the material should be non-porous, not to let the hand materials and other materials to go inside of it. Now, this doesn't mean that glossy coatings and highly polished handles are good to use. So if it's too glossy and polished, this, on the other hand, could also create problems if it's too slippery, for example, okay? Electrical and heat isolation. These kind of properties are important for handles that, especially for power hand tools. Now we are dealing right now, we are discussing basic systems, hand tools that are used with no power, okay? But when you talk about electrical and heat isolation, this is for the more, if you're designing a powered hand tool, so mechanical system that uses electricity, then you must use materials that prevent you to get an electric shock when using it, and also heat. This tool cannot produce heat. This tool cannot produce heat, okay? Or cause me an electric shock. So handles made of plastic and rubber are recommended because they are isolation, they have isolation properties. For electrical, they have electrical and heat isolation properties, the plastic and rubber. Okay, so many hand tools you see are always have plastic, rubber, plastic. This is actually a rubber. This is not the rubber is a plastic, but it's a plastic type, okay? So this is rubber. Here we have plastic and rubber together. Here we have plastic, rubber. It's always used again and again because it's a good design choice for most hand tools. Other shape features, so other physical characteristics that you need to keep in mind. Sometimes hand tools have bent handles with a curve. Do you see bent handles? Bent, not straight, bent, okay? To try and keep the hand and wrist in a straight, neutral position. So the bending of the handle sometimes helps the hand and the wrist to stay in a neutral, comfortable position. So if you use a straight handle, sometimes I have to bend my wrist during work to compensate for that. But if the handle is bent, this already creates for me a more comfortable way of using this tool because I don't have to bend. So my wrist stays straight because the handle is already bent. If this is straight, I have to bend my wrist. Okay, So, but this condition to make the handles bend only works if the tool is used in the position that it was designed for all the time. You cannot, a tool that has a bent handle, you must always use it in this position, in this way, to perform a task. You cannot use it in a different way. So this design is very good if you use this tool only in a certain position. But if you need to use it in 2-3 different ways, then this will prevent you from using it. Then you will have to put a straight handle. Straight handle means you can use it in different positions. It's more versatile. So it depends on really what tool are you designing, okay? So to design the handles bent or straight, it's very important design decision, depending on the tasks that you need to perform with it. So the best design will depend on the task for which it will be used. General checklist. This general checklist is just a simple checklist written down for you to, when you design a hand tool, just to check, okay? Did I do this? Did I do this? Did I do this? Okay, you just read it through. Now it's general checklist, meaning that not always all of these will apply to your hand tool. Sometimes there are other choices you need to make, but it helps you to keep you in track when you're designing a hand tool, to make sure that you, took into consideration the important points that you need to consider. So, did you design the grip surface non-slippery? This is important in most hand tools. Yes or no? Okay, so it's a checklist. It's the grip surface should not have sharp edges which can hurt you. Okay, grip surface is thermally isolated. Okay, so it will not get hot or cold quickly when working in a hot or cold environment. Okay, let's say, for example, I work in an environment which is very hot outside in the summer. Okay, and my tool is under the sun all the time. So when I touch it, will it be hot? So it should be thermally isolated with correct materials for this environment. The grip length, okay? Did you make that correct? Does the handle end in the palm of the hand, okay, or not? The angle of the handle. Angle of the handle is formed so that work can be done while keeping the wrist straight. So the angle, is it a curved? Is it straight? Does it have an angle? Many things, okay? Did you design the tool to be able to be used even when wearing gloves? Now, many tools are used while you have a glove on your hand. The glove will make your hand bigger. Your hand, you have a certain size, but when you put a glove on, it will make it bigger. So can you use the tool even when with a glove on? Can the tool be used with either hand? So if you're right-handed or left-handed, is it comfortable to use or not? Okay, this also has to be designed correctly. Is the tool shaped and designed to minimize the effort, strength required to accomplish tasks? So how much effort do you need? This is a hand tool. So the work, most of the work done is by the human, okay? But you can still design it in a way to reduce the effort and strength needed. The design, the shape will help you with that, okay? And did you take into consideration the variability of hand dimensions? So which anthropometric data did you use to design this tool? For which hand types? So that even if there is small variability, like smaller hand or bigger hand, they can still use it comfortably and safely. Okay, so this is the end of the lecture regarding hand tools. And some of the things that you need to take into consideration when you analyze hand tools for design problems, to discover design problems, and when you design hand tools to solve design problems. So all of these things we discussed, again, are basic things, okay? Basic general things that you need to pay attention to when you design a hand tool and when you analyze a hand tool. So this section will help you in your first project. We will talk about it, of course, later after we complete all the lectures. Thank you for watching and study well, okay?